In this last unit, we're going to examine some other relationships that can exist besides the straightforward linear pattern line relationship. So we'll start by looking at a scatter plot. A scatter plot is another way of showing a relationship, but in these kinds of patterns, it's not a perfectly straight line. What we do is we plot all our data, our points, and they should sort of follow a shape as opposed to making that line. The shape that we see we call correlation or a co-relation. There's some sort of relationship between these two things. And when we describe it, we describe the trend. Like in general, this seems to be happening. Okay? As we get taller, our feet get bigger. But that's not true for every single person. You could be pretty tall and have small feet, okay? Or be pretty short and have big feet. So here's an example of this graph right here. Temperature and ice cream sales. So as I go towards the right on this graph, so as the temperature goes up, what seems to happen to ice cream sales? Well, ice cream sales are also going up, but not perfectly in a straight line. Okay, the temperature went up pretty high here, but there was actually less ice cream sales than there were at this dot, right? Even though the temperature was higher. So if I was describing this, I would say as the temperature goes up, I always start the bottom one first, ice cream sales also go up. We call this our trend, the general pattern. Not perfect, not a straight line, not linear. I can't make an equation from it, but I can get a rough idea. There are three different types of correlations, correlations we have to examine. And we talk about them in terms of the direction of the line that's on the graph, the imaginary line. Maybe picture it in your head. And so a positive graph, one that goes up to the right, we just saw one. As temperature goes up, so do the ice cream sales. Both variables increase together. So we go right and up. We could have negative relationships. As one thing goes up, the other one goes down. Maybe, I don't know, the more time you spend gaming, the less time you have to do homework. Right? One goes up, other goes down. More gaming, less homework. So if you think of the words more and less going together, that would be a negative relationship. More and more, it's a positive relationship. And then, of course, if no correlation, there is no pattern, just a random sort of dots everywhere. The relationship between how long it takes you to get to school every day and how much sleep you had last night. Well, maybe you had lots of sleep and you got here really fast. Or maybe you didn't have lots of sleep and you got here really fast. Right? It could be those two dots right there. They have nothing to do with each other, just a random pattern of dots. What does sleep have to do with getting here today? And that's, of course, you're thinking about being late because you're sleeping in, and that's a whole other thing, right? So we have three types of correlation. I want you to be able to describe for me. So you're going to give me the words positive, negative, or no, or none. Okay. So let's take a look at some of these things. Here's some graphs. For each, we're going to describe the correlation and the trend. So height and age of students. So my dots seem to be going up to the right. So I'm going to call this positive. That's my correlation. And the words I'm going to use for my trend are as age increases. So I always do the bottom one first. So does heights. As one goes up, so does the other. So up and up. Look at the second one. Height and travel time to school. Hey, we just kind of talked about that one. That's a random guess. Looks to me like there's no pattern here. Dots are kind of all over the place. So I'm going to say none. And if there is none, there is no trend. So you can't have a trend if there's no pattern, right? Let's take a look at the third one. Water temperature and depth. Well, it seems to me as I go to the right, the graph is going downwards, so down and over. One's going down, one's going up. So that's a negative correlation. As depth increases. So as it gets bigger, it's going to the right. Water temperature, that's some really bad spelling there, sorry guys. Temperature decreases. Okay, so as we go to the right, things are going down, which makes sense. The further down the lake you go, the colder it gets. Anybody who's been swimming, it should make sense. Okay, so two ways of describing every time. What visual do you see, and what does it actually mean? And the last thing we've talked about with scatterplots is a line of best fit. A line of best fit is kind of like the lines we've been drawing last unit, except for they won't go through all the dots. We're not playing connect the dots here. What it's going to do is it's going to try and show the relationship between the patterns by giving a rough estimate of where the lines should go, okay, by going through or as near as many points as possible. It won't go perfectly through all the dots by any means. In fact, it may not go through any dots, but it should roughly follow what's happening in the pattern. So this is one we started with here. We said as temperature goes up, so do ice cream sales. And the line of best fit went through, well, kind of went through 1, 2, 3 dots. We had 1, 2, 3, 4 below and 1, 2, 3, 4 above. It's a by eye fit. You have to use your best judgment where you think it should go. And just to point out, lines of best fit should never go this way, and they should never really go this way either. And there should be a diagonal line. Let's take a look at an example here. This is our last one. Okay, during a science experiment, room temperature water is slowly heated. The temperature at different points is recorded in the table below. So we're doing an experiment. Okay, as time goes by, the temperature of the water goes up. We're boiling the water. We've got some data. We're going to do exactly what we did with the last unit. We'll plot our data. So after 2 minutes, temperature is 30. So on this graph, they gave us the scales and the labels. So we can just plot our data, 2 minutes, 30 degrees right there. We got 4 and 45. 4 and 45 is right there. 6 and 50. It's right there. 8 and 68. 8 and 68. I'm going to have to estimate on this one because 68 is not a nice number for us. So somewhere around there. And 10 and 75. 10 and 75. Right about there, I'd say. Okay. There's a scatter plot. They're not perfectly straight line. It's pretty close, but not perfect, which is reasonable. That's what happens in a experiment. Okay, some more information, or more questions here. Part B. How would you interpret the point 5 and 48 on this graph? Well, if I were to put 5 and 48 in this graph, I would say that, about there, at 5 minutes, the temperature is 48 degrees. That's kind of what these information is giving us, right? That's what a dot is. 2 pieces of information at the same time. Okay, correlation. Definitely positive. It's going up and to the right, for sure, for sure. Okay, trend. That's not too bad to do. As the time increases, so the bottom one first, what happens to our temperature? So does the temperature. As one goes up, the other goes up. It's the whole idea of positive, right? If I know positive, I know they're both increasing. Okay, sketch the line of best fit. Okay, so here's where we take our best estimate. So I'm going to grab a ruler for this. Easier to make a straight line that way. I'm going to ask myself, if I put this ruler on the graph, where should I angle it so it goes through or near as many dots as possible? So I've got a bunch of dots here. I think that would be not bad right there. I'd end up with like 2 below, 2 above, and kind of 2 on. So I'm going to draw my line, just like that. And make sure I go through the vertical intercept there. So make sure I find my initial value in case I need that. I always like those. Okay, but notice I have the green dot up here on it. The red dot's pretty much on it. Green dot just misses. So I've got one that misses, two that miss above or below. I got the two above. Your line doesn't have to match mine perfectly. It's we're sketching. We're making our best estimate. All right. And using your line of best fit, predict how long it will take the water to reach its boiling point of 100 degrees Celsius. So, with my ruler, I actually need to maybe extend my line just a little bit to make sure I hit 100 degrees. 100 degrees is way up here at the top, right? Okay, so how do I do this? I find 100, go across to my line, and I have to go down, and I'm going to say it's about just over, I'd say 146 minutes maybe. I'm sorry, 14 and a half minutes maybe, not 146, those are decimals there. About that, right? Just a little bit past 14 and a half, I'd say. It's an estimate though, so if you estimate slightly different than me, that's okay. If you said 20 minutes, I'd say no, and if you said 5 minutes, no, but around 14 minutes, 14 and a half minutes. Let's look at G. You look at your friend's table and see they've written down 785. Why might you suspect they've been sloppy? Well, let's think about our graph. 785, so 785 is like here. So if we follow that up, there's a dot. They're saying there should be a dot right there. Would that dot make any sense to you? It doesn't follow my line of best fit by any means. So I'd suspect they'd be sloppy. This line does not, oops, it's not a line, this dot does not follow the line of best fit. It's okay to be off the line of best fit. I'd be totally fine if I had a dot at 7 and, I don't know, maybe even 65. That'd be okay right there. Or 7 and 55 would make lots of sense, right? Here. But 7 and 85, that's way off the line. Okay, lines of best fit won't go through all the dots. They should be near most of the dots. If you get something way off like that one, it doesn't make much sense. Okay, that's Scatterplots. That's our next lesson. I need you to be able to do 3 things for me today. You have to be able to describe for me direction and trends. You should be able to make a scatter plot and then draw and use your line of best fit to figure out the relationship between information.